On March 6, 2025, a pivotal moment in lunar exploration is set to occur as Intuitive Machines aims to land its lunar lander on the Moon. The mission, which incorporates NASA technology and scientific objectives, is scheduled for no earlier than 12:32 p.m. Eastern Standard Time. This event marks a significant milestone in the ongoing collaboration between private aerospace companies and NASA, highlighting the increasing reliance on commercial partnerships to achieve ambitious space exploration goals. Intuitive Machines, a key player in the burgeoning commercial space sector, is making strides to demonstrate its capabilities in lunar exploration. The upcoming landing is expected to pave the way for future missions, including those aimed at establishing a sustained human presence on the Moon. As space agencies worldwide renew their focus on lunar missions, Intuitive Machines is well positioned to contribute significantly to this renewed interest. Simultaneously, NASA is taking steps to prolong the operational life of its Voyager spacecraft, which have been exploring interstellar space since their launch in 1977. With power dwindling, NASA engineers have made the difficult decision to deactivate specific instruments aboard Voyager 1 and Voyager 2. As Voyager 1's cosmic ray subsystem was turned off on February 25 and Voyager 2's low-energy charged particle instrument is set to be deactivated on March 24, these measures are part of a strategic effort to extend the missions of these iconic spacecraft. Suzanne Dodd, Voyager project manager at NASA's Jet Propulsion Laboratory, emphasizes the urgency of these actions, stating, "If we don't turn off an instrument on each Voyager now, they would probably have only a few more months." The decisions underscore the challenges faced by deep space missions as resources become increasingly limited. The Voyager twins, having traveled an astonishing 29 billion miles, are the farthest human-made objects from Earth, and their contributions to our understanding of the universe are unparalleled. As they continue to relay valuable data from beyond the solar system, NASA is keen on ensuring their longevity even as they operate on dwindling power supplies. In a related domain of concern for NASA, the space agency is grappling with the implications of spaceflight-associated neuroocular syndrome (SANS) on future Mars missions. As NASA looks ahead to a potential crewed mission to Mars within the next 15 years, the long-duration journey presents unique challenges, particularly concerning the health of astronauts. SANS affects vision and can lead to serious ocular changes, including swelling and alterations in the eye shape. Despite years of research, the precise causes and effective treatments for SANS remain elusive, prompting NASA to classify it as a critical risk for upcoming missions. Aerospace optometrist Tyson Brunstetter, who studies SANS, reflects on the unexpected complexity of the syndrome, noting, "I said it's NASA. They'll figure it out in 6 months. And yet here I am, part of the team trying to figure out what exactly is going on." As NASA prepares for longer missions beyond low Earth orbit, addressing SANS is becoming increasingly urgent. The agency is exploring various strategies, including potential pharmaceutical interventions and mechanical devices designed to counteract the effects of microgravity. In another significant development, the Boeing Starliner capsule is poised to return to Earth following the successful Crew 10 launch, underscoring the ongoing advancements in human spaceflight capabilities. This mission highlights the importance of reliable transportation for astronauts as NASA continues to expand its presence in space, facilitating both scientific research and exploration. As the landscape of space exploration evolves, the interconnected challenges and successes faced by organizations like Intuitive Machines, NASA, and Boeing signify a new era of collaboration and innovation. The outcomes of these missions, whether they involve lunar landings, interstellar exploration, or addressing health risks for astronauts, will be pivotal in shaping humanity's future in space. With various projects underway and ambitious goals on the horizon, the coming years promise to be transformative for space exploration as both public and private sectors work together to unlock the mysteries of the cosmos. NASA astronauts Suni Williams and Butch Wilmore are preparing for their long-awaited return to Earth after an unexpectedly extended mission aboard the International Space Station (ISS). Launched in June 2024 as part of Boeing's Starliner crewed flight test, their stay originally intended to last just a week, has stretched into nearly 9 months due to technical complications with the spacecraft, as the duo anticipates reuniting with their families. They reflect on their unique experiences in space and the challenges they faced during their extended mission. During a recent news conference from the ISS, Williams expressed relief at the prospect of returning home, saying, "It's been a roller coaster for them, probably a little bit more so than for us," referring to their families. The prolonged absence has been particularly challenging for loved ones who have awaited their return with little certainty about the timeline. Williams and Wilmore have been making the most of their time in orbit, engaging in scientific experiments, conducting spacewalks, and fostering international cooperation by interacting with Russian cosmonauts. The astronauts' return has become a topic of political discourse in recent weeks, as figures like President Donald Trump and SpaceX CEO Elon Musk have made comments suggesting that the astronauts were abandoned in space due to political motivations. In response, Wilmore stated during the press conference, "We don't feel abandoned, we don't feel stuck, we don't feel stranded," emphasizing their preparedness for an extended stay. This sentiment underscores the resilience and adaptability inherent in human spaceflight, as both astronauts had trained for contingencies that could lead to longer durations in orbit. The delay in their return was primarily due to the Starliner's issues, which prompted NASA to send the spacecraft back to Earth in September without its crew. The astronauts were subsequently integrated into the Crew 9 mission, which is set to return with them aboard a SpaceX Dragon capsule. The Crew 10 mission, slated to launch on March 12, will usher in their replacements, allowing for a seamless handover before Williams and Wilmore can finally make their journey home. Reflecting on her experiences, Williams remarked, "Living here gives us a unique perspective, not just outside the window, but on how to solve problems." She expressed a desire to preserve the inspiration she has gained from her time in space, further highlighting the profound impact that such missions have on astronauts' outlooks and problem-solving abilities. As the Crew 10 launch approaches, Wilmore and Williams are looking forward to their return, which is currently anticipated for March 19. Their journey home will mark not just the end of a remarkable mission but also the culmination of years of development and testing for Boeing's Starliner. The lessons learned from this extended stay will undoubtedly shape the future of human spaceflight as NASA continues to push the boundaries of exploration. The return of these seasoned astronauts not only signifies a personal homecoming but also reflects the broader narrative of resilience and innovation in space exploration. As Williams encapsulated her feelings about the mission, "I don't want to lose that spark of inspiration," emphasizing the lasting impact of their experiences both on themselves and the future of space travel. In an anticipated return to Earth, NASA astronauts Suni Williams and Butch Wilmore are preparing to leave the International Space Station (ISS) after an extended mission that was originally intended to last just a few days. The duo, who embarked on their journey aboard Boeing's Starliner spacecraft in June 2024, faced unforeseen delays due to technical issues with the Starliner, which ultimately necessitated their transfer to a SpaceX Dragon capsule for their homecoming. During a news conference held from the ISS, Williams and Wilmore reflected on their time in space, expressing both excitement for their return and gratitude for the experiences they've had during their prolonged stay. "It's been a roller coaster for them, probably a little bit more so than for us," Williams noted, acknowledging the challenges faced not only by the astronauts but also by their families on the ground. The crew's unexpected length of service has included not only conducting scientific experiments and engaging with international counterparts but also breaking records. Williams, for instance, has achieved significant milestones during her mission. The astronauts' return to Earth is now contingent on the arrival of the Crew 10 mission, scheduled to launch as early as March 12 aboard a SpaceX Falcon 9 rocket from NASA's Kennedy Space Center in Florida. This mission, which marks the 10th rotation under NASA's Commercial Crew Program, will facilitate a handover before Williams and Wilmore can join their fellow astronauts in the Crew 9 Dragon capsule for the journey home. Complicating their situation has been recent political rhetoric surrounding their extended time in space. Both President Donald Trump and SpaceX CEO Elon Musk have suggested that the astronauts were abandoned due to political motivations, a narrative that Williams and Wilmore have sought to clarify. "We don't feel abandoned, we don't feel stuck, we don't feel stranded," Wilmore asserted, emphasizing that their experience aboard the ISS has been positive and well coordinated. He diplomatically acknowledged the disconnect between their lived reality and external narratives, underscoring that they were informed of their situation and decisions made by NASA. The astronauts' extended stay has drawn attention not only for the mission's challenges but also for Musk's controversial comments about the circumstances surrounding their return. Musk claimed that he had offered to bring the astronauts back earlier, a statement that both Wilmore and NASA Administrator Bill Nelson have refuted, stating that there was no formal plan or discussion regarding such an offer. The logistical decisions made by NASA were based on operational realities, including budget constraints and the readiness of spacecraft as they prepare for their return. Both astronauts have expressed a desire to carry forward the unique perspectives gained from their time in orbit. Williams remarked on the importance of retaining the inspiration and problem-solving insights that come from living in such a distinctive environment. "I don't want to lose that spark of inspiration and that perspective when I leave," she said, signifying the profound impact their mission has had on them. With the Crew 10 mission on the horizon, the countdown to their return is officially underway. As NASA transitions to a new phase of its commercial crew program, the experiences of Williams and Wilmore will undoubtedly serve as a valuable reference point for future missions and the continued collaboration between various space agencies. Their journey underscores not only the complexities of space travel but also the resilience of those who venture beyond our planet. The future of space exploration remains bright, with many more developments anticipated as NASA and its partners continue to push the boundaries of human spaceflight. In recent advancements within the aerospace and climate science sectors, two major initiatives have emerged that showcase the intersection of technology and environmental challenges. NASA's rotor optimization for the advancement of Mars exploration ROMPS project is pushing the boundaries of aerial exploration on Mars, while a partnership involving WTW, the Karlsruhe Institute of Technology KIT, and NASA is tackling the rising risks posed by hailstorms exacerbated by climate change. NASA Ames Research Center is currently conducting tests on helicopter blades designed specifically for Martian conditions as part of the ROMPS project. Between 2024 and 2025, these blades were subjected to rigorous testing in the Planetary Aeolian Laboratory Palo low-pressure chamber capable of simulating Mars atmospheric conditions. The tests revealed that these newly optimized blades could be spun at up to 4,000 rpm and air density approximating that of Mars, which is about 0.015 kilograms per cubic meter. By comparing the performance of the ROMPS blades against those of NASA's Ingenuity Mars helicopter, researchers found that the new designs could significantly enhance flight capabilities, allowing for extended range, greater speed, and increased payload capacity. "Our simulations indicate that the optimized ROMPS blades outperform the Ingenuity blades, enhancing the potential for future aerial missions on Mars," stated a representative from the ROMPS team. The next phase of testing will aim to push the RPM limits further and explore various collective angles, suggesting promising developments for Martian exploration. On a different front, WTW has announced the continuation of its collaboration with KIT and NASA's disasters program to improve hail risk modeling. This partnership, which has flourished over the past decade, aims to address the increasing severity and frequency of hailstorms, particularly in Europe, where recent years have seen substantial insured losses. As climate change continues to alter the dynamics of hail formation, understanding how key variables such as storm frequency, intensity, and geographical distribution are evolving has become crucial for the reinsurance industry. Daniel Bannister, Weather and Climate Risks Research Lead at WTW, highlighted the urgency of the project, stating, "Hailstorms are a growing concern for the reinsurance industry, particularly as climate change introduces new uncertainties around their behavior." The updated version of the original Willis European hail model will integrate a refined analysis of satellite data to enhance the accuracy of hail hazard assessments. This improved model aims to provide valuable insights into the spatial and temporal distribution of hail risks, ultimately aiding the reinsurance sector in better anticipating and managing these challenges.
Professor Michael Coons from KIT emphasized the importance of this collaboration,
noting how it integrates cutting-edge science with practical applications in the economic sector, thereby benefiting the public at large. Meanwhile, NASA's Benjamin Scarino remarked on the significance of their long-term satellite data, which allows for a comprehensive understanding of severe storm activities and risks. As these initiatives unfold, they underline the vital role that advanced technology and collaborative research play in confronting both extraterrestrial exploration and earthly climate challenges. The future holds promise for enhanced Martian exploration capabilities through the RONX project, while the partnership between WTWKIT and NASA may pave the way for a deeper understanding of hail risks in an era of climate uncertainty. Such advancements not only reflect scientific ingenuity but also the pressing need for innovation in addressing the complexities of our changing environment. As NASA gears up for its ambitious plans to send humans to Mars within the next 15 years. A significant hurdle looms large, a perplexing condition known as spaceflight-associated neuroocular syndrome (SANS). This syndrome poses a potential risk to astronauts' eyesight during prolonged missions in the microgravity environment of space, raising serious concerns about the health and safety of crew members embarking on a journey that could take upwards of 9 months each way. SANS manifests as a range of ocular changes, including optic nerve swelling, flattening of the eyeball, retinal wrinkles, and alterations in the eye's refractive index. These changes can impair vision, and although researchers have studied the syndrome for over a decade, the underlying causes remain elusive. Dr. Tyson Brunstetter, an aerospace optometrist at NASA's Johnson Space Center, reflects on the initial optimism surrounding SANS when it was first reported in 2011.
"I thought it's NASA.
They'll figure it out in 6 months," he recalls.
Today, however,
SANS is recognized as one of NASA's red risks for the Mars mission, alongside other serious concerns such as radiation exposure and mental health challenges. While astronauts have experienced visual changes during missions aboard the International Space Station (ISS), where the duration is typically 6 months, the longer duration and isolation of a Mars mission could exacerbate these issues. Approximately 2/3 of astronauts on extended ISS missions have reported visual acuity changes, with only a fraction severe enough to be classified as SANS. Fortunately, most symptoms tend to resolve after returning to Earth, though some changes like eye flattening may become permanent but can often be managed with prescription lenses. The exact cause of SANS is still a matter of investigation, but researchers suspect that fluid shifts in microgravity may play a significant role.
In a gravity-free environment, excess fluid accumulates in the head,
potentially increasing pressure and affecting the eyes.
However, this explanation does not account for why only certain astronauts develop the syndrome.
Scott Smith, a nutritionist at Johnson Space Center, suggests a combination of factors, including genetics and possible vitamin deficiencies, may increase susceptibility.
His research indicates that astronauts who develop SANS tend to have higher levels of the amino acid homocysteine, which is linked to dietary deficiencies in key vitamins.
In response to these findings, NASA is considering trials of dietary supplements to mitigate the risk of SANS. Additionally, researchers are exploring mechanical countermeasures such as venoconstrictive thigh cuffs and devices to redistribute bodily fluids to alleviate the impacts of microgravity on astronauts' health. As scientists continue to uncover the complexities of SANS, the broader implications for future missions to Mars remain critical. The prospect of including artificial gravity systems to counteract microgravity's effects is also being considered.
Although engineering challenges abound,
innovations may range from large centrifuges to simpler human-powered devices that simulate gravitational forces. The urgency of addressing SANS is underscored by the impending timeline for Mars exploration. With a mission to the Red Planet on the horizon, researchers are committed to finding solutions to ensure astronauts can safely navigate the challenges of long-duration spaceflight. There's a lot of people out there with ideas, Smith emphasizes, highlighting the collaborative effort necessary to overcome this significant barrier. As NASA's plans for Mars take shape, the lessons learned from tackling SANS will be invaluable in shaping the future of human space exploration. ensuring that the vision of reaching the red planet is not clouded by unforeseen health risks. The journey to Mars is not just about crossing vast distances, it's also about safeguarding the health and well-being of those who dare to venture into the unknown. In an exciting development for lunar exploration, Intuitive Machines is poised to make a significant mark on space history with the anticipated landing of its lunar lander Athena scheduled for March 6, 2025 at 12:32 p.m. Eastern Standard Time. This mission aims to deliver NASA technology and conduct groundbreaking research in one of the Moon's most intriguing regions, the South Pole. With a focus on locating subsurface water ice, this landing marks another step in humanity's quest to return to the Moon and establish a sustainable presence there. The Athena lander represents an evolution from Intuitive Machines' previous mission, which involved the Odysseus lander, the first commercially operated vehicle to successfully land on the lunar surface. Although Odysseus achieved a historic landing in February 2024, it toppled shortly after, underscoring the challenges of lunar missions. This time around, the team is hopeful that Athena will maintain its balance upon landing, allowing it to deploy its payloads effectively. Intuitive Machines has designed Athena to land at Mons Mouton, a flat-topped mountain approximately 100 miles from the Moon's South Pole, a site that promises to provide valuable insights into the lunar surface and its resources. The choice of Mons Mouton is strategic. It is believed to contain frozen water and other volatile compounds that could be crucial for future human exploration. The lander will deploy a drill known as Trident, which is specifically engineered to extract lunar soil and analyze its composition for water and other essential elements. NASA's continued investment in lunar exploration through partnerships with private companies like Intuitive Machines highlights the agency's commitment to leveraging commercial capabilities to advance scientific objectives. The main payload on Athena is a drill for NASA that will extract lunar soil to be sniffed by a mass spectrometer for frozen water and other compounds, said Joel Kearns, NASA's Deputy Associate Administrator for Exploration in the Science Mission Directorate. This dual focus on science and potential resource utilization is critical for the long-term goal of establishing a human presence on the Moon. Leading up to the landing, mission controllers are making adjustments to Athena's descent trajectory to ensure a safe landing. As reported by Josh Marshall of Intuitive Machines, the spacecraft will pivot to a vertical position at an altitude of 450 meters rather than the previously planned 400 meters. This precautionary step is intended to allow flight controllers additional time to confirm altitude measurements and enhance landing accuracy. Athena's mission is not just about landing, it also includes deploying several rovers and testing new technologies. Among the payloads are a small rover designed to create 3D maps of the terrain and a drone that will hop around the landing site to search for traces of hydrogen and ice deposits. Additionally, the mission will test a 4G communications system developed by Nokia, which could facilitate communication between various lunar assets in the future. This week marks an exciting moment for lunar exploration as Athena's landing follows closely behind the successful landing of Firefly Aerospace's Blue Ghost lander, which touched down on March 2. As part of NASA's Commercial Lunar Payload Services program, both missions symbolize the growing role of private companies in space exploration and the agency's strategy to harness their innovation for scientific gain. However, not all news from the lunar front is positive. Concurrently, NASA's Lunar Trailblazer, a satellite designed to scout for water on the Moon, has encountered severe communication issues, leaving mission controllers scrambling to re-establish contact. The challenges faced by this probe underscore the complexities of space exploration and the need for robust systems to ensure mission success. As the world tunes in to watch Athena's descent, the implications of this mission extend far beyond the immediate moment. The data collected could provide insights that shape the future of lunar exploration and pave the way for human missions to the Moon and beyond. With Athena aiming for a successful landing, the potential for discovering vital lunar resources and advancing our understanding of the Moon's geology presents an exciting frontier for scientists and engineers alike. As we await the outcome of this pivotal mission, the future of lunar exploration looks promising, with numerous missions planned in the coming months and years that could further unlock the secrets of our nearest celestial neighbor.